Okay, lesson 45 is finding the line best fit, and we're going to do this by first analyzing some types of graphs. So first, let me see if I can turn my brightness down a little bit. Maybe that'll help. Okay, so on this first one right here, is this going to be, since you already see the answer, is it going to be positive or negative? It's positive because it's going up from left to right, right? Looking at this one, is this one going to be a negative or positive? Negative. It's falling, right? It's going down. Right here, is there a definite answer? No, I would say it's more positive because they're going that way, but it looks like an outlier here, outlier there. It's kind of scattered everywhere. They're wide, okay? So we would say that this has no correlation or hardly any correlation, okay? So if you type in all these points into your calculator, it'll still give you a line because it does this big long formula that you don't want to know, trust me. And it'll give you a line still that'll be best fit for this line, this data, but it's not really a great correlation, okay? So what we'll talk about is the correlation coefficient later on, but for right now we're just going to focus on producing the line best fit. Okay, so regression is the process of identifying the relationship between variables. So that's when we talk about linear regression, and we're producing this line, we're just saying the relationship between the variables makes this line, and that's the best one fit. Okay? A measure of strength is called the correlation. So here we have a strong correlation. These points are really close to each other. It has a strong correlation. Okay? It almost makes a straight line. Here, it's still a kind of strong correlation because we can tell it's negative, but they're more spread out. Okay? Over here, there's no correlation because there's really no definite answer. The closest thing to a correlation is these set of points that are kind of in a straight line. Okay? So correlation is how strongly they go together, and regression is just talking about the relationship, whether it's going positive, negative, or if they're close fit to each other. So we're going to produce the line best fit. Flip the page to example 1. Example 1 asks us to create a scatter plot of this data and describe the correlation. So I trust that you guys can create a scatter plot. Bless you. I trust that you guys can create a scatter plot, but the only thing that I don't trust you guys with is that you're going to be lazy in creating them. So I want to go over what I expect to see on these data points. Okay, first of all, you're going to need an x and y axis. If there's going to be negative data points, then you have to extend it into the second, third, and fourth quadrant. But for these are all positive, so I'm only going to draw in the first quadrant, noting that this is the origin, right? So in this chart, I see that one of the sides is going to be number of people in the household. The other one is average pieces of mail per day. I need to figure out which one's going to be my x values and which one's going to be my y values. Okay, for the most part, it's the very first one you see is your x values. So the number of people in the household. And I would agree that that's where this one's going to go to. So I would have to label my x's number of people in the household. Okay? So what they're trying to establish is there a relationship between the number of people and the amount of mail that each place gets? So the next one says average pieces of mail per day. So that's clearly going to have to be my y. So I'm going to just abbreviate average mail so I don't write it all the way out. Save me a little bit of time here. And normally we would have to write a title. Okay, if there is a title that goes with the whole chart, go ahead and write it in. Then I have to establish my increments. Because I see that my x's are going to be 1 through 6. I would probably just go up by 1 on my x chart. So 1, 2, 3, 4, 5, 6, 7. So just labeling those is obvious. On the bottom side, I see that I'm going to be starting at 4 and going to 9. If there's a big jump in your numbers, like say it starts at 1,000, you might put a break in your graph. But if it's not, obviously, just start at 0. Okay? And then work your way up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Label at least a few of them so that we know what your increment is, and then we can go on with our lives from there. For the line best fit, they give you lots of options for finding this. I want the most precise line you can create. So they'll say, go ahead and graph these points. So they'll give you the points 1 and 4, and we'll put the 0.14 on there. And it says 2, 6, so we'll put 2, 6 on there. Next one, 3, 6. And then 4, 9. And continuing on, 5, 8. And 6, 6. Okay, so there's really not a straight line that we can create with this, but does it have a correlation? Is it positive or negative? If there is. There's a positive correlation. It's kind of going like that, right? So what they'll tell you is find the line best fit, and they'll say draw a line in there somewhere and find the equation of it. That's basically what they tell you. So yes, I trust that you guys are smart enough to do all of that, but I want a precise line. So I want you to take your calculator out, go to Stat, type them in to your list. You might have to clear out your list before you do that. So I'm going to go ahead and clear mine out. Comma is right above your 7. Okay, so enter in the list. It's 1, 2, 3, 4, 5, 6 on the X's. Oh, and I messed them up. Look at me. And then 4, 6, 6, 9, 8, 6.
Wait, how do you put out in this?
Go Stat, go down to Clear List.
Okay.
You're going to enter in second L1, comma, second L2, and then clear those lists out. Anybody still working on their list? Give me a second. All right, after that, we're just going to do linear regression. That's going to be our line best fit. So when you see the word find the line best fit, immediately think, okay, I need to go to Stat, enter in my list, go to Stat again, tab over, linear regression, enter, enter, and bam, spits out my answer. Okay? I want that in rounded form, clearly, but that is what I want to see as an answer. Okay? So for me, on this one, I would write my line best fit is y equals point, I'm going to round to the hundredths place, 5, 4, x plus 4.6. Okay? I'm pulling that right off my calculator. Did anybody not get those? Need a hand?
I got it now.
Good deal. Okay, we're going to talk about something called the correlation coefficient. It is the strength and direction of a linear correlation that is measured in R. So they'll say R. Do y'all guys already have the R showing up on yours? No? Okay. So we might have to turn that on. But it is a value from R normally ranges, or it does range, it won't be anything bigger than that. R will range from -1 all the way down to positive, or all the way up to +1. So R will be somewhere between these two numbers. Okay? It will never be bigger than 1, and it will never be smaller than -1. Okay? The closer it is to the absolute value of 1, the stronger the correlation. So let me show you what some of these would look like. The closer these numbers are, so the closer the dots are, the stronger the correlation. If it's negative slope, then the R is going to be negative. They just use R as the value. Okay? Right. And the higher the number. So here it's going to be like -0.9 something. So let's see what they say. -0.93. So it's pretty strong. On this next one, they're pretty widely spaced, but it still has a correlation. What do you think? Positive or negative? It's definitely negative. And they're kind of spaced out, I'd probably say somewhere in the 50, 60 range. 60s. Okay? So we can estimate what they are just based on their spacing, and the more we see them, the more accurate our estimates will be. But for our calculator, it would give us an exact number. Noticing this one, that one's really spread out, right? It's almost no correlation at all. It's going to be below 50s for sure. Probably is in the 20s, 30s, somewhere in that range. That one's 21. Okay, here, this one's really, really strong right there, and then opens up a little bit. I'd say probably still 80s, 90s. 80s. Okay, so it's really, really strong right there, and then opens up kind of big at the top. But it's definitely a positive correlation, right? These that definitely has a positive correlation. Here it can kind of go either way, but I would say positive just because there's only really one outlier that would put me in the negatives. So that one was positive, right? Okay, does anybody got questions over correlation values there? I'll go over that here in a second. Because it's different on my calculator than it is on yours. Example 2. So I trust now that you guys can graph it. Just remember that you have to have your labels. Labels, labels, labels. And then your increments have to be accurate enough. Okay? So on example 2, it says create a scatter plot of this data and estimate the correlation coefficient. Then predict the number of people who took the stairs to the 4th floor. So looking at this chart, they put these numbers on that chart. Okay? And we look at these and they kind of already drew their line best fit. And we can do that by putting it into our calculator. So this is definitely a what kind of correlation? Positive or negative? Negative correlation. It's kind of strong, I would say, because they're pretty close to this line. So when you consider what R is, you would say, if I drew a line, how close would all of my dots be as I went down that line? Okay? So when they're really close, it's going to be in the 90s. When they're really spread out, it's going to be below 50s. Okay? So here they're really strong, it's in the 90s. And it says it was negative 0.97. Okay? So when we estimate it, we would say, I think it's somewhere between 0.8 and 0.9. You know, that kind of thing. Okay? But it'll never be bigger than 1 and never smaller than negative 1. Okay? And then it'll ask you, based off of this line, what would you predict on people going to something else? You know, what floor? So over here at floor 12, we would be in the negatives, right? Well, that's not possible. You can't be in the negatives. So the question will say, sketching the line best fit, that is there a good prediction of the number of people that will take steps to the 4th floor to be 12? So here it goes 4 up to 12. Would you say that's pretty close estimation? 4th floor, about 12 people. As they farther the floor gets away, the less people that'll go. If it has a 9-story building, negative amounts of people are going to go. Doesn't make any sense around that part, but anyways, you get my point. I think that's all, actually. Example 3 is going to do the same thing.